first one is how
Maybe you
many
can
you
start from Michael Kwan just now.
yeah, I've listed the questions already.
Okay, thank you.
Yeah. So the first one is asking how many VAV units can the fan optimizer handle? So BELIMO's fan optimizer is 1 unit of fan optimizer to 8 units of VAV. But if there's more VAV units, then more fan optimizers can be used, and the fan optimizer output of the first one can be linked to the second, and the second can be linked to the third, and so on. And the last one will be linked to the fan. So that's how it will be used in a project. So for a bigger project with more UAV boxes, it's better that this fan optimizer program or logic is built into the BMS control. And next question is asking the totalizer for the VAV flow or to calculate the average flow rate. That is dependent on the programming by the BMS. The controllers don't have this feature built in. And next question is asking what's the normal pressure drop for a VAV? It's normally 20 Pascal. If you're not considering add-ons or the options like multi-outlet box or electric or water reheat. So you can use this number 20 Pascal for all your different flow, different box sizing. So just one number, so it's easier for you to do your calculation. The reason why it's so low is because there's just a negligible pressure drop from the averaging sensor and the damper parts. And there's also a static pressure regain. If you look at the box, when the air velocity goes from the inlet into the attenuator section, the air slows down because of the larger cross section. And then that's why the pressure drop is relatively low. All right. I think no more questions there. All right.
I think there's one more from Lee Zaina Hin.
Yes, there's a comment that says that maybe a heater is still required. I suppose so. It depends on the design of the sizing of the AHUs and how many zones are using the series fan VAV.
I think, sorry, here. I think before that, still have another question.
Yeah.
For the off-coil temperature set point.
Uh-huh.
Yeah. I noticed that because the VAV system, the set point will be at the off-coil temperature of the primary AHU.
Yes.
So due to the static requirement, then we know that the affinity law, some pressure we cannot ram down too low. Then there might be have area that is overcooling. This is common issue for the VAV. How you tackle this?
What do you mean overcooling?
Okay, you see, the VAV system is based on the pressure built up in the duct, supplier duct.
Yeah,
right?
constant pressure.
So you need certain static to go to the furthest point. So the affinity law play in. So you cannot ram down to too low. So in order to achieve the airflow, you need to maintain certain static pressure again, but it might be overcooling because the more airflow. Especially the area that nearby to the AHU, we always face this problem. Because of the supply air temperature is continuous supply the dew point temperature. That's that point. Yeah.
Mm-hmm.
So how to mitigate this?
I'm sorry, I still don't get the.
Okay, for example, this the airflow that you require for the system is 10,000 cmh. Okay, so the system design actually is 20,000 cmh AHU. So you need to ramp down to 50%. But to ramp down to 50%, you only left 25% of the static pressure. But we required, let's say, minimum 50% of static pressure. So you cannot ramp so down. Maybe you only can ramp down to 70%. So the airflow will be at the 14,000 cmh instead of 10,000 cmh. So they might be leaking somewhere lah. So certain area, I believe they will receive more airflow. Then is overcooling. This is one typical issue for the VAV lah. That we're facing if you set based on the off-coil temperature.
I think I need to talk with you separately to understand your problem better. I'm sure there's a problem, but it's just that I don't understand it now. Because
if you read through the affinity law, I think you quite understand what my question.
The affinity is about fans RPM relation to pressure.
Yeah, because the pressure is power of 2. So you ramp down based on the flow rate, and you cannot achieve. Normally we base on a static control. So there might be certain area that is over airflow. Right.
If you're using pressure independent VAV boxes, you won't get underflow or overflow.
Then where is the flow that supply to?
If you're using pressure independent, you will just provide that set flow as long as there's sufficient static pressure in the duct to satisfy all the VAV.
That's why I mentioned is, let's say the airflow that we require actually is less than the static pressure that we require. Yes, it's based on pressure build up, but we cannot ramp down so low a certain area that you cannot achieve the static pressure.
Yeah, correct. That is probably a control issue on that particular project. So the static pressure has to
I don't think it's a control issue. It's a typical issue because there always has a lower limit for this VAV system. You cannot go down too low, the static of the AHU.
Yes, of course, yes. And any equipment design, there's a range.
Yeah.
I mean,
if you cannot go too low, then you might have the over airflow issue. So this is how to mitigate. Maybe you need a bypass or what?
You don't have an over airflow issue if you are using pressure independent. The only issue you will face is that the noise from that particular VAV box will be very high if the pressure is high.
Okay.
So like your case, if you are using a CAV system and there are some VAV in that CAV system.
No, it's a VAV. It's a full VAV system. It's not mix of CAV.
Why I'm saying is that it could be it's a different thing. I'm saying because just now you mentioned bypass. So you will only use bypass if you have a CAV system, but there are some zones which are VAV. Then
I mean bypass is maybe a proposal to mitigate this, but not the system that we use. But what we're facing is the VAV system. But you always have a certain area that is overcooling because the temperature that you set is based on the dew point, the off-coil temperature, or either 12 or 14 degrees C.
I see. I'm sure there's a fix for this thing. I just need to understand your design or the schematic better and propose a fix. Maybe add a branch differential pressure. I mean to add a differential pressure controller or a damper to maintain a certain part of your.
Especially those is nearby to the AHU one.
Right. So additional pressure control need to be added in your system.
Yeah, this is the answer.
Yeah.
Right. Thank you.
Okay.
Okay.
All right. So we move to part 2.
Yeah, sure.
Okay.